Let's do a Pro Photo app benchmark on Mac laptops versus PC laptop and see how they compare against each other. This is ArtIsRight. Before we start, subscribe if you're new and hit on the bell icon so you'll be notified every time I upload cool new videos like this. Many of you have been asking for a Mac and Windows comparison, and here it is. The reason why I'm doing this is because I recently purchased a RAZER Blade 18 to do more content with Windows and color management, and I need a faster PC laptop. And yes, because I do have it, I will also game on this machine as well. But I feel that this is the perfect opportunity to take a really top spec gaming laptop and apply it to a professional workflow to see how it performs. Now, let me say that this is not going to be the normal occurrence for this channel. I'm not going to be buying PC to doing testing, although if any PC manufacturers are watching this and you want to send me your machine to do testing, I'd be more than happy to do so. Secondly, this is not really created as a Mac versus PC. One's better than the other to show performance superiority. That's not the case. What I really want to know is if I take these computers and run it with the current software, the current apps are on the market right now, the current components that are in the machine, how do they perform in relation to each other? This is going to give us a lot of insight, a lot of perspective, and it will also inform many of you as well if you're thinking about switching from a PC to a Mac or a Mac to a PC. This will tell you exactly how it performs in these pro applications. So with that in mind, I also want to mention that if you find this useful, I'll leave a link to my tip jar in the description. YouTube Super Thanks works as well, or the best thing that you can do for me is to just subscribe to the channel if you haven't already. If you have already subscribed, thank you so much. I greatly appreciate it. But if you also want to contribute funds that will help run and support this channel and will go into a repository for future hardware purchases, because these computers, I mean, yes, they can be pricey. So we're going to take a look at Mac versus a RAZER. And the reason why I'm doing this is because I always love RAZER as a company. I think that they are pretty much the Mac computer of the PC world. Yes, Microsoft does make Surfaces, but a lot of times the components are not the most powerful. They really more compare with like the MacBook Air per se, more of like the consumer level Apple machine. Whereas if you want a really powerful one, you would be looking at more of like the RAZER, good design, CNC aluminum chassis, a lot of Apple philosophy kind of built into the RAZER there, and that's what I really love about their product. And yes, I know Microsoft does make the more powerful laptop, but those are far and few in between. So anyway, with this in mind, we're going to be comparing these two primary systems. A 16-inch MacBook Pro M2 MAX SoC. This is pretty much stock configuration, 32GB unified memory, 1TB SSD, $34.99. Comparing this to a RAZER Blade 18, this is Intel Core i9, 13950HX, the top chip that they have. This is 24 core, 8 performance, 16 efficiency. Nvidia GeForce RTX 4070. This is a $300 price increase. Is a custom built to order for this one, or a built to it. 32GB memory, 1TB SSD. This is coming in at $3199.99. Now, one thing I want to say about the RAZER is that yes, you can really go in and configure this and really upgrade your machine more. $600 more will get you to 4080. $1,300 more will get you to 4090, which is a fairly pricey machine. But if you need those type of performance, you need those type of performance. So the one other thing I also want to point out in the price differentiation between the configuration we're looking at as well is the screen. So Mac has a Retina or HD DPI. It can do HDR, it has a refresh rate, the ProMotion 120, and the pixel pitch is 254 pixels per inch, and a high resolution display. You don't really get this on the RAZER Blade 18. For this, you get a 2K display, that is the QHD 240 Hz, so the refresh rate is double, better for gaming. And however, the pixel pitch is only 168, so it's not really quite passing that 200 pixels per inch threshold that make it HD DPI. Now, the other machine that I don't have from RAZER, and I didn't think about purchasing that one, was a 16-inch because the current one has a mini LED, and you can go between high resolution mini LED, and you can restart the system and go to like 1080p and get a higher refresh rate. I really want to see how that works. So RAZER, if you want to send me a machine, I would definitely love to test that out. But anyway, this is the configuration that we're looking at. And in addition to all of this, I'll be adding a whole bunch of Apple reference system as well, from the 16-inch, 14-inch MacBook Pro, M1, M2 generation. I'll also be adding in results from my Mac Studio as well, both the M1 Ultra and also the M2 Ultra, just kind of as a baseline for comparison. You can see there's a whole bunch of MacBook Air in the lineup there, and there's also 13-inch MacBook Pro. I mean, there's really too much to list, so you're going to be able to see that from the charts that I am about to share. A couple other things I want to share before we really get going with this is that all the Mac data that you see right now, these are all based on reference testing, meaning that they are previous test results in comparison to all the new tests that I've ran on the RAZER machine. Now, with this in mind, I have also done some differential testing on the Mac as well. And between those historic data that I'm using versus the current configuration, the time differences between the two are really minor. So that's why we're using a lot of these reference data in comparison to all the new tests on the RAZER. As far as test configuration go, as I usually say on this channel, I can't test every configuration. So some of the data needs to be extrapolated. But in this particular instance, the essence of this is to really, compare PC components versus Mac. So there's really not a lot of configuration we can really be looking at anyway, or data extrapolation, because I haven't tested that many PC yet. As usual, I'll be taking a pro photographer perspective on this. I photograph events, I do architecture, so I deal with, or portrait shoots in long days. I deal with thousands of images at a time. I want to see a machine run fast. I don't want to see it slowing down in duration. And that's the reason why I'm doing all these tests. As far as responsive and Lightroom goes between these two machines, they are very similar to each other. And if you use Lightroom Classic, you will know that after you use the program for a while, it does take up a lot more memory, and the program does have a tendency to slow down. That's just pretty much the nature of the program. Maybe restart your computer. That definitely helps a lot. All these apps are done on a single app testing to see how the silicon is performing between an Intel CPU versus Apple Silicon, CPU, GPU, all those other things. I don't want to do multitasking because that's not the essence of this test. What I really want to know is how the silicon is performing based on these different apps, so you can make the best decision possible. Now, a couple other things I want to share with you as well is that on the RAZER, there are different modes you can use. There's silence, there's the boost mode. I ran them in both configuration, and timing are pretty much exactly identical to each other, so it doesn't really make that much of a difference. But do know that I ran the computer in boost mode, and a lot of the data you're going to see here are just based on the boost mode data. But like I said, they're pretty much just about the same, and anything that can utilize GPU has been enabled on the system. So my thoughts going into this is, coming in with the RAZER, I have high expectation. And the reason why is because I keep seeing in my comments on the video too that, oh, Apple GPU will never beat Nvidia. Okay, totally understand that, perfectly fine. But I don't think that's where Apple is really taking their GPU on these SoC either. In using it, well, the results kind of mix, and you're going to see that in just a moment. So first, let's talk about some observation. Power being the biggest difference. So 16-inch MacBook Pro, both M1 Max and M2 Max, Apple shipped this with 140 watt power brick. On the RAZER itself, this comes with a 280 watt power brick. It's definitely drawing a lot more power than the Mac is. That means pretty much the Intel CPU and also the Nvidia GPU are really power hungry chips that are running on the machine. Now, the other thing too is that I have also been noticing that the fan would kick in much sooner and run much louder. And even if I run the machine in silence mode, my RAZER, the moment I kick a Pro app in, start to do a task, the fan just start to run. On the Mac, it's just most of the time remains silent, and when it gets pushed really hard, when the heat's there, then the fan will ramp up slowly first, and then sometime it does run loud, but those are really far and few in between. Now, once you see the result, I will say this, it is not RAZER's fault. I love RAZER as a brand, and yes, they are doing a good job with the design, but you have to think of RAZER as a component integrator. Whereas Mac, they designed their own SoC to ship, they designed their own operating system, so they code it all in-house. They have the full vertical. Everything is designed in-house and is manufactured somewhere else, but it's all Apple design. There's DNA, there's integration all over the place. When it comes to RAZER, CPU, they're relying on Intel or AMD. GPU, they're relying on AMD or Nvidia. The operating system that they run on, they're relying on Microsoft, that is really designed to run on as many computers as possible. So there's only so much these computer manufacturers can really do for optimization. And a lot of times it doesn't really integrate fully into the operating system either, meaning that, yeah, there's certain things you're going to see. For example, it starts up with the branding logo instead of the Windows logo. You'll see the apps that's really used to control the firmware of the machine running as a background app, but it doesn't necessarily integrate into the system settings on the OS in general, whereas Mac, everything just integrates in. This is something that RAZER has their hand tied behind their back, and this is the reason why when we're taking a look at these results, we're not really comparing particularly RAZER and Mac per se, we're really comparing all these other PC components that are in there against a Mac. All right, so let's talk about reading the specs. Here are how you can read the specs. I'll leave a link to this as well. If you want to come back and take a look at the cheat sheet, you can. And I'm sure there's some machines that I'm also missing from this list as well, but you can extrapolate from this data. Now let's take a look at Lightroom Classic. Let's start there. 1-to-1 preview for 1000 Nikon D850 file. So I want to see how fast this is, and this has been the exact same set of files that I used from the earlier benchmark that I've done on this channel, so they have remained consistent for the longest time ever. And we can see right now that all these two machines, I mean the Mac, they're performing pretty much similar to each other. This is a CPU based task. The only variation between these two are the GPU, and also one has a bigger chassis. That's why it's slightly faster by about less than a minute or so. The RAZER though, however, is taking around 2/3 of a time longer to really do that, or like about 2 or 3 times the amount that Mac is really taking. Interesting result there. A couple of things in the observation of machine. I pulled a task manager and look at the performance. The initial run, when the chip is cooled, the CPU is cooled, it peaks many of the cores. After a while, and I mean like maybe about a minute or two in, it gets hot, everything's dropped. Some of the cores stop running altogether, the fan ramps up really hot. I've been monitoring the temperature, it's sitting at the very top of the time. So the machine is going through thermal throttling, and even though there's a vapor chamber to keep things cool, Intel chip is running really hot in general. And that's the big difference between a Mac versus a Intel, and you can see. And this is also another big indicator why Apple decided to bring their SoC design and everything in-house, because they are really efficient. It's pulling less power, it's dissipating less heat, and is a much better way to look at machine and to computing in general. If we take a look at this now, compare with the other machines, we can see the studio at the top. These are the Pro Mac laptops you can see there, and it's not even in that cluster. So let's rescale this chart a little bit and add in a few more machines. Interestingly enough, RAZER is performing just where the 13-inch MacBook Air is performing. Now, the MacBook Air can be about half or a third of a price of this RAZER. That's the first thing. And secondly, it doesn't have any fan in there, so it's all passive cooling. For instance, this MacBook Air base model, 810, 8GB, 256, is pretty much beating the RAZER by a few minutes there. Very interesting result when it comes to this, but there's more to really talk about here. So this gives us a perspective into how the Mac is doing on Pro Creative Workflow and how the PC components are doing in the Pro Creative Workflow. So what about export? 1000 files from, again, the same Nikon D850 RAW file to full-size JPEG. When we take a look at this, this is a CPU and GPU based task. So the 4070 Nvidia RTX is really kicking in and helping doing a lot of these heavy lifting. Timing is a lot closer to each other. This is much better to see than what have come before. Now, the other thing I also want to point out is that on the Mac, going from 38 GPU core to like 30, I mean, you're really talking about less than a minute time improvement. And yes, this one has more heat dissipation, this one has less, but it also has less GPU as well. Something to think about there. And when we also compare the, for example, 16 and 14 inch with the Max SoC and inside, many people say that, oh, we can't get this in a 14, it will thermal throttle. Well, here it is compared to a really beefed up Windows laptop. So this puts everything into perspective really quickly. I'm glad though that this is clumping much closer to the Pro machines. Now, with this in mind, when we take a look at this chart, comparing all the other machine in lineup, the Studio, they're in a class of their own. They're more like the Xenon chip for Intel. However, the RAZER is really holding into this group with all the Pro machine, and that's really great to see, because the next cluster you see there are all these MacBook Airs and 13-inch MacBook Pros and so forth. So I'm really glad to see that, you know, it's really clustering in with the Pro machine. So that's good to see. Now let's take a look at Lightroom Classic HDR Merge, 9 Nikon D810 files. So we're going to take a look at this. Timing wise, most of these Mac machines are within a margin of error of each other, only about a second or two apart, with the RAZER coming in at a little bit longer, 43 seconds. Now, this is solely a CPU based task, and it tells you how the things ramp up. And because we're only doing one HDR merge, this is really not long enough time on the CPU to really heat it in extreme duration, yet it still takes a little bit longer. So this gives you a perspective on that as well. What about Lightroom Classic Panorama Merge? The same thing I've done before. 14 Nikon D810 36 megapixel file to create a 314 megapixel image. That is a huge file. Now this is a RAM and CPU based task. And even though the amount of RAM are the same, we can see that the CPU is not really running quite as fast as the CPU inside these Apple Silicon. So these 12 cores are doing a fantastic job. Now, is this one running that much further behind? Well, kind of is, but kind of is not at the very same time. Relatively speaking, this is about maybe, what, 20% slower? It's not really that big of a deal, but this, again, puts everything into perspective for us. Let's compare this against all the other machines in the lineup. RAZER comes right in there in the middle, just above all these MacBook Air, although there's a MacBook Air that just beats it by a few seconds right there. I find this result rather interesting, but again, it's not doing too shabby in this task. All right, so Lightroom Classic AI Noise Reduction. Now, this task so far is really supposed to be running on the neural processing engine core on the Mac. However, it hasn't been doing that even in the latest version of Lightroom Classic that I've tested as it is filming. So it's still running on the Mac GPU and it's not using the neural engine just yet. And on the PC side of things, it will definitely just run this on the GPU. With this in mind, yes, the 4070 is faster, but this is one of those where we're really putting this to a raw test for a task that just really go in and really utilize that GPU. So yeah, is Nvidia faster? Sure. But we're only talking about a win here by only a few seconds at the very most on a task that doesn't really peak the GPU that much and doesn't take that much time. So in duration, yeah, Nvidia may be faster in many senses, but it also runs hotter and it has to cool down a lot more and cap the speed and throttle versus Apple can just keep running in many senses. Something to think about there. And because this was a new test that I added in, some of these machines that I have before are reference data. I don't have these machines anymore, so I couldn't test them, but this will give us an idea. And RAZER is coming right in the middle there. Not too bad, much better than, for instance, a MacBook Air. And also, for example, MacBook Pro M2 MAX. However, it's not really beating out quite all these like Mac Studios as yet with, for example, 128 gigs or 64 gigabytes of memory and one Ultra M2 Ultra. You can see there at the very top. It gives us some perspectives as far as how things are going, but it's only a few seconds slower than the Ultra machine, so it's not that bad either. What about Lightroom? This is the cloud version, or what they call Lightroom Desktop. And when we compare this, this is one of those tasks where the export is using the CPU, GPU, and RAM all in combination. And yes, GPU acceleration has been enabled on this particular task. Yet it takes a little bit more than double the time to finish compared to these two machines. So something to think about there. Now this, how does it compare? So let's take a look there. RAZER is falling into that purple chart. And if you take a look at this right now, this is really more in the MacBook Air territory again. Passive cooling, a machine that costs half or 2/3 less than the RAZER. That's what we're looking at right now when it comes to all these intensive tasks. Again, observing the CPU performance. I mean, the GPU is running, but the CPU is really bogged down because of the heat. Because it has to really throttle, it has to shut down some of the cores. Whereas on the Mac, it just pretty much keeps churning along. This is how we get this cluster of time at the very top for the Mac Pro machines, or the Pro chip inside the laptop anyway. What about Capture One? So this is the Capture One import preview. This is set to the largest one possible. This is a CPU-based task. And for this, the timing is really close to each other. But I've mentioned this in numerous testing already that Capture One, it's not an app that has been coded well to utilize all these system resources on the CPU side of things. And part of the reason why they're doing it that way too is because it's really designed for tether workflow. So they're really creating the app so that you can tether to it. It doesn't use too much system resources, so it doesn't bog down the system. However, as I always say for this with Capture One, if you're listening, give us an option to toggle between just editing or tether capture so we can go in and utilize more CPU performance on the system if we want to. For example, we're not doing tethering in these specific instances because, you know what? Guess what? You are really targeting the pro users that are doing a lot, just the edit in general and not necessarily tether capturing, but this option is not available yet. So something to think about there. Timing, really close to each other, just a touch behind, not that bad at all. Now, when we compare this to the rest of the machine in lineup, RAZER comes up kind of on a little bit on the bottom, but I mean, take a look at this. The M2 Ultra and also the M1 Ultra is not faring that much better than this machine. Again, this really comes down to optimization and utilization more than anything else than just looking at the machine. But if we take a look at this, I mean, it's also definitely beating out some of the MacBook Pro machines, and is also clustering above many of the MacBook Air that has passive cooling. So something is really working right there. It also indicates that pretty much Capture One is a little bit more tuned to run better on Intel chips than on Apple Silicon at this point in time, even though it doesn't beat everything clearly just yet. For this, timing wise, we see that the RAZER is taking close to about an 8-minute longer in this export time, so probably like about a little bit over 20% slower than what it is compared to the Mac. Now this is pretty much a GPU task, and this is when we're talking about not just only one task where we're doing, for example, the AI noise reduction. It really just goes in to peak the GPU performance for a very short duration, and yes, on that it's much faster, but in long-term duration on these type of export, we're really seeing the result right now. And also keep in mind that this is not an independent standalone card that plugs into a PC desktop. This is the video card that's integrated into the laptop that's supposed to, be smaller, be more efficient, runs cooler, all those things. And compared to a Mac though, that's also in a laptop, you do get to see the performance there. How does this compare to the rest? Well, RAZER is really coming in the middle there. It's also still clustered in within the Pro machine, which is really great to see. I'm glad that it didn't really drop down into, for example, the Air territory again, very similar to, for instance, the Lightroom Classic 1-to-1 preview. And this gives us an idea for their performance. However, it's still clustering in at the very bottom of the list. Now, granted, also this is a 4070, not a 4090. I wonder how the 4090 would do. Maybe it will take this off by a few seconds, or excuse me, a few minutes, and it will move it up a few slots on the list. I don't know about that one, but some of the thoughts there that I have. Now, when it comes to Photoshop, for all these tests, I have been using Lloyd Chamber Digital Lloyd Test. Leave a link to his website in the description. He makes really great testing for these. And yes, they're all synthetic Photoshop tests anyway, but at least his I can time result. Sadly though, his test is only running on Apple script, meaning that it's only really for a Macintosh system. So I am at this point in time looking for a better benchmark system that's cross-platform compatible, and I'm still searching. If you know of any good one, let me know in the comments which one you think will work best. Now, Puget System also make a benchmark as well, but I didn't choose to include it because as of this point in time, it doesn't run natively on Mac OS. So I have to really change Photoshop so that it really runs on Rosetta in order to run this test, so I'm not including the result from Photoshop. And now let's take a look at video. So for this, on the Mac side of things, I have been using Final Cut Pro, and there's no Final Cut Pro for PC. So on the PC side, I have been using Premiere, but I've also run independent testing off camera as well, and I have verified that the export time for both Final Cut and also Premiere on the Mac side are very similar to each other because they all dip down into the hardware encoder decoder engine that Apple have built into the SoC itself. So timing are going to be very similar, but this is pretty much just based on going in there in Premiere. And for this, I am using Adobe Media Encoder that's supposed to go in and utilize multiple cores. I've also set this to CUDA. I also try OpenCL export as well, which is not really that much better at all. In fact, OpenCL is just about the same time, and then when we do software, it takes that much longer to do these type of exports. So this is using CUDA export that is really going in there and targeting the Nvidia GPU, and we can see that for 4K export H.264. I mean, simply put, the MacBook Air with passive cooling is doing that much better by a factor of more than 2 on these machines. So we get some idea there as far as how this is performing. And no, I did not test this in Resolve. This may be something that I can probably test in the future. I mean, if you really feel strongly about that or have some thoughts about how the result's going to be, leave a comment in the section below. I'd love to hear about them. H.265 HEVC 8 bits, when we take a look at this, this is pretty much by a factor of almost 4. It's taking that much longer to finish a task compared to, for example, the MacBook Pro and also the MacBook Air of the bunch right there in that group of cluster. Now, the reason why the MacBook Air and all these machines with passive cooling, even though their Apple consumer level machine is doing well, is because Apple have gone in and they built in an encoder decoder engine inside those SoCs. Where you see all these other Pro machines doing much better, it's because Apple have double or quadrupled those encoder decoder engine inside the machine. Now, on the PC, we're still relying on CPU and GPU to do this task, which is the reason why we're seeing the time taking much longer. And by the way, this is just an 8-bit 4K 420 clip on a 10-minute timeline. That's pretty much it. This is not anything intense at all, but something to note there. ProRes 422, this is by a factor of almost 7. You know, the amount of time that it takes much longer to finish the task, and the MacBook Air is even going through this much faster because, again, Apple built in those encoder in. Now, this is really just to give us some perspective as far as how the machine is performing. So we can see right now that for all these machines, it's kind of really a mix. It really depends on what you're doing, but just based on this configuration alone and a very similar price point, there's really not a clear winner in any specific categories. In the short burst, for example, like AI, yes, but the winning is so small, it's only a few seconds. But when we do anything in duration that requires CPU or GPU or both in combination, heats tend to get the best of this machine and slow it down, which is the reason why we're not seeing that good of a result. Now, lastly, we're going to take a look at Adobe After Effects, and I'm using Adobe Benchmark for this. So let's see how this performs. Now this, because it's really going in and just utilizing the raw CPU on the machine, and After Effects has just really been designed in a way to optimize for a lot of Intel CPU, because I mean, it's been running on Intel for the longest time. Apple Silicon is kind of like newer to the equation. What we get is a performance that is pretty much about like, you know, 2/3 faster than a 14-inch MacBook Pro. So we get to see some ideas there as far as how this is performing. It's winning, and this is the one that is really winning by a big margin enough that I would say, like, yeah, this is something to really look at. How does this compare to the other machine in the lineup? Now, I don't have too many machines here. Again, this is one of those new tests that I've added later on, but we can see that the RAZER is coming at the very top. And for instance, it's really beating out the M1 Ultra, and also it's really close to the M2 Ultra. So if this is a task that you're using this machine for, yeah, PC is really doing a really good job here. But if you're a photographer, you will see that for the most part, it's doing a decent job. It's not really doing the best job, and some of them are not doing that much better than, for instance, a 13-inch MacBook Air. All right, so with all this in mind, what does this really all mean? As I said before, the result we're seeing are just really a mix between decent and some are really good, for example, After Effects, but the video one are not really quite as clear that it's really doing that much better either in both Premiere export and also inside Adobe Media Engine. And I use both to do export and to test them, and their timing is about the same. This is really trying to go in and optimize all the systems or all the settings already so that it utilizes the most amount of power in the system, and yet that is still the time we're getting. So that's my thought of that. A couple of other things to just reiterate certain aspects, as well as that the problem with this machine in general is not RAZER's fault, like I said before, is that they are a component integrator. So they're relying on Intel, they're relying on Nvidia, they're relying on AMD, they're relying on so many other companies, they're relying on Windows from Microsoft to really get the job done. So certain level optimization can be there, but I mean, if Intel is providing this group of CPU that runs on this heat, there's really not a lot that RAZER can do, because RAZER is not really designing their own CPU at the moment. Where Apple can just say, we want to optimize for 25% improvement in performance, and we want thermal to go lower, and we can push hard to do that. Because whatever we did, even though the improvement may not be to what we specified, we're still going to win against the previous generation that have come before with a much better efficiency. So those are things to think about. Now, the other thing is that this is part of the reason why when Apple have their, for example, 2019 Mac Pro, the big tower one with the Intel Xenon chip, they ship these computers with the option to put in afterburner cards so that you can encode and decode faster, because the Intel chip and the AMD GPU does not really do a job in that aspect that well, and that's the reason why they put those there. Now, most of those afterburner cards are really for Apple ProRes, but you know, it's just something to really think about when you're taking a look at this. So at the end of the day, you really have to think about if you want to do a platform change or not. I think that for photographers, I mean, if you're not stuck on a certain platform, or you're willing to, you know, take some downtime, relearn some of the intricacies of a different operating system, moving platform can be a good thing. But I also want to advise you to take this with a lot of gravitas as well, that changing from something that you've been used to, for example, if you've been using PC for a decade, 2 decades, you're used to that. There are things that are used to. Having to do a switch, especially if you're in the midst of production to a Mac, probably not the best idea possible. And it may be more economical for you, even though the machine is running slower, to just maintain the PC and just keeps getting faster ones, or keep buying new ones that are faster, rather than moving the platform altogether. But if you're looking for a computer to have a lot of vertical, that runs fairly cool, great thermal efficiency, all those other things, I say that Mac is definitely a good platform to look at as well. And I hope that this will inform your decision enough about how these machines are performing in relation to each other. And it also gives us a perspective as well. Looking at Mac, for instance, well, a 14-inch with the Max SoC, it's going to run hot. It's going to thermal throttle. Well, I have that machine, and it's really not that bad at all. I'm using it on the road all the time, and I'm able to get my work done. The other thing, too, that I also want to mention is that when you purchase these machines, you're just going to use them. You will have pretty much most of the time, 1, maybe 2 machines in the studio. You're not going to be comparing them against each other the way how I'm doing. So a lot of these are just perspectives, and you're not really going to notice that big of a difference either. So another thing to really think about there when you're choosing this. Now, I have a lot of guide for Mac and so forth. I'll leave links to them in the description. You can search them on my channel as well. Anyway, I hope that you find this information helpful and enlightening. If you have any questions or comments, leave them below. Give this a like, subscribe, and hit on the bell to renew, and in art we trust. I just finished filming, and there was one more observation that I forgot to share with you. During this filming, these machines were shut off, they were turned on, and they're just pretty much sitting here as a prop. There's no active apps or anything running on them. On a Mac, it's been pretty much silenced this entire time. No hums whatsoever. On the RAZER, the fan ramps up every now and then. Now, this is not unique to the RAZER. I also have a Dell XPS 15, and it does the same thing where even though nothing may be running on there, the fan just ramp up to cool the machine down. This is another big difference between Mac and PC on a daily usage. And personally, I like the machine to be silenced like this much better than the fan ramping up every now and then, because the chip is running too hot and it needs to dissipate heat or whatever that may be. Some interesting observation there that I want to share with you.